Okay, 3-4, linear programming, which is the last section of chapter 3, short chapter here. So we're going to kind of just add a little twist to what we've been doing in 3-3, which is graphing our systems of inequalities. All right, so two objectives here. First, to find max and min values, maximum and minimum values of certain problems. And then we're also going to be able to solve word problems with linear programming. So we'll see both of those. All right. So linear programming, objective function, constraints, and feasible region are our four vocabulary phrases. So keep an ear out for those as we go through here. All right. So before we get to any of that, let's make sure we have the skills we need to accomplish this section. So the first one, we need to be able to solve systems of equations. So for number one, I'll do number one for you. You try 2 and 3. Number one, to me, is lined up for not substitution, but I'm drawing a blank on my word. Not substitution, but elimination. Sorry, elimination is what we got, but we're going to need to switch the signs around so we can add straight down. We'll get 0 equals negative 5x, and we'll get plus 10. Let me rewrite it down here. 0 equals negative 5x plus 10. So 5x equals 10. So x equals 2. There's one part of my answer. Let's plug it back in. We can just go right to the top equation. Negative 3 times 2 plus 3. Y equals negative 6 plus 3. So y equals negative 3. All right, so there is problem 1. Take a second and see if you can do problems 2 and 3. When you're ready, press play again, and I will do problem 4. All right, quick reminder on how to do the section from 3-3, system of inequalities. So x is greater than or equal to 5. I'm going to go out to 5. 3, 4, 5. This is going to be a solid line. And I'm going to shade on the right, but I'm going to wait on the shading until I have my next line. Y, I'm going to go up to 6. That's my intercept. 1, 2, 3, 4, 5, 6. And I'm going to go down 3 and over 1. Down 3 and over 1. Down 3 over another one. Down 3 over another one, and so on. And this would be a dotted line. So we'd have it like that. Extend that line down a little further so we cross. And I want to be to the right of x and above y, so our region would shade in like that. All right. So take a few minutes and see if you can get 5 and 6, and we'll go over the answers to those in class. Once you're ready, press play again, and we'll move on to this investigation. All right, if you're ready, let's take a look at this. So it's a music question. Suppose you want to buy some tapes and some CDs. So this is an old problem for when I was in high school. Definitely no tapes anymore. And CDs, I don't know. Do people buy CDs? I don't. I'm not sure if anybody does. Anyway, you can afford as many as 10 tapes or 7 CDs. And just kind of looking ahead here, I'm seeing that x is going to represent tapes and y is CDs. So I can get 10 tapes at the most. So x is going to be less than or equal to 10. I can't get more than 10. I can get less than that, but not more than that. Y is going to be less than or equal to 7. I could buy 7 CDs if I wanted to, or fewer. Okay, don't have to go over. I want at least 4 CDs, so y has to be greater than or equal to 4. 4 is going to be my smallest number, my minimum. And I want 10 hours of recorded music. Each tape holds 45 minutes. So on this, I'm going to say 45 times a tape plus 1, so 60 minutes for my CD has got to be less than or equal to 10 hours, which is 600 on here. And so 45, does that go in here? Not evenly. We can at least divide by 15. That would give me 3x plus 4y is less than or equal to 40. Just divided everything by 15, and I've got that inequality. All right, so now we have a number of inequalities here. So we have 4 different things going on, and we're going to just see how to graph this in a second. But for now, does each ordered pair satisfy the system? I'll do the first one, you check the rest. So 4 comma 7. Let's go through this. Is 4 less than or equal to 10? Yes, it is. So we like the first one. Has to work for all 4 of our inequalities. Is y less than or equal to 7? It's exactly equal to 7, so we're okay. Is it bigger than 4? Yes, it is. And so for the last one, we're going to have to plug this in. 3 times 4 plus 4 times 7. We get 12 plus 28, and that's equal to 40. Is 40 less than or equal to 40? It's exactly equal to 40. So that one works. So it worked for all 4 of them, so we're allowed to keep it. If it works for 3 but not 1, doesn't work. It has to work for all of them. Okay, so try the next 4 points, plug them in, see if they're going to work. All right, so let's take a look here. Linear programming. It's a technique that identifies the minimum or maximum values of some quantity. All right, so this quantity is modeled with an objective function. An objective function is, as an example, this part here, the limiting factor. Okay, so the objective function is what we want, the best case scenario of what we want to occur. All right, so the model with an objective function, what we want to occur. Okay, but we're limited. You can't buy as many tapes and CDs as you want, so we're limited by constraints. All right, so constraints are things that limit our ability to meet our objective function. They limit our ability to maximize or minimize our equation. All right, so the first paragraph of the investigation describes the constraints, right? So these are constraints. We've got to be less than 10. We've got to be less than 7. We've got to be greater than or equal to 4. All right, so we have all these inequalities, and we got the last one, right? We can only have so many. And then our objective function would be within those constraints, buy as many CDs and tapes as we can. All right, so we want to maximize our enjoyment within those constraints. So here's what it's going to look like. All right, so we've graphed 4. We've got 4 inequalities here, right? X is less than or equal to 10. So that's this line here. Okay. We've got to be above y equals 4, so that's this line. We've got to be below y equals 7, so that's this line. And then this line here, this diagonal one, that's the 3/4 x plus y is less than or equal to 10. They took my inequality here and divided it by 4 again. So you get 3/4 x plus y less than or equal to 10. Same thing. If you were doing intercepts, cover up the x, y would be 10. You can see that that's where it's hitting up here. And if you did 10 times 4, it's 40 divided by 3. You're going to get 13 1/3, which is right about where they're hitting, right down there. Right? So we're constrained inside of this trapezoid here. And now we think about, okay, what's our objective function? Our objective function is to get the most CDs and tapes that we possibly can within those constraints. All right? And what we're going to find is that the graphs of an objective function will have a maximum or minimum at a vertex. So in this problem we have 1, 2, 3, 4 vertices. And the place that's going to maximize our objective function is going to be at one of those 4 corners. All right? So we could test them, but I think logically it makes sense that to get the most CDs and tapes we can, we're going to be at this point out here, because that would give us the most x and the most y possible. All right? So that would maximize our objective function. And there it is again. If there's a max or a min, it has to happen at a vertex, at one of the vertices. All right? Okay, so let's do an example here. We've got a couple constraints over here, and I'm going to graph them. First one, I'm going to go down 3. 1, 2, 3, make a dot. From there, I'm going to go up 3 and over 2. Up 3, over 2. Oops, over 2. There we go. Connect those. All right, the next one I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. Oh, just made it. And I'll go down 1 over 1. Okay. And then I say x has got to be greater than 0. So red line here. There's x equals 0, and it's got to be greater than y equals 0. So there's y equals 0. All right, so let's figure out where are we. We've got to be above and to the right of those. I want to be above the first line I drew, so above this line. And I want to be below the second line I drew, so this line here. So I think it's pretty clear. We're going to be in this region, represented by the blue color. All right, so let me shade that in. And now, if we say, okay, what's the value of p at each vertex? Well, let's see what the vertices are. Here's a vertex. This is 2, 0. This one here is 3, 4, 3. This vertex down here is 0, 0. Right, here's another one. 2, 3, and our fourth one up here is going to be at 7, I'm sorry, flipped them around, 0, 7. Those are our 4 vertices. So what is the value of p? All right, so p, they give us an equation, right? So this is our, if we back it up, this is our objective function. They give us some objective function, 3x plus 2y. So we need to plug that in at each point. So this would be 3 times 0 plus 2 times 7. And so that would give me 14. This one here is going to be 3 times 4 plus 2 times 3. And so that's going to be 12 plus 6, or 18. That's for this one. This one down here, 3 times 2 plus 2 times 0 is going to be 6. And our last one, if I plug in 0 and 0, 3 times 0 plus 2 times 0, we get 0. All right? So we have the values at each vertex. And you can see here that the place where we would maximize 18 would be at the point 4, 3. The place where we would minimize 0 would be at 0, 0. Okay? All right, so go ahead and go back in there, and we're going to change up the constraints. We're going to take the same graph, but instead of doing 3x plus 2y, switch it up so it's 2x plus 3y. All right, so find the new vertex values, all right, and figure out which one maximizes and minimizes. Okay, so let's take a look at the real world example here. All right, so we've got mixed nuts and roasted peanuts that we're selling, but we have to pay for them first. And so we can order no more than 500 total cans and packages of both. So we know that, let's make mixed nuts our x and peanuts are y. We know right away that x plus y has got to be less than or equal to 500. Right? Can't have more than 500 of them total. We can spend no more than $600 total. So we got to be less than 600 or equal to it. Right? And let's see how much we pay. It's $24 per case, and we get 12 cans, so that's $2 a can. Or $15 split between 20. So that'd be 15 over 20, which is 3/4. So plus 75 cents. Is that right? 20 packages in a case, $15 a case. Yeah, so plus 75 cents for a package of peanuts. Right? And so those are our restrictions here. All right? We also know that x has got to be greater than or equal to 0, because it doesn't make sense to sell negative amounts of mixed nuts. And y has got to be greater than or equal to 0. All right? So let's go ahead and see if we can graph this. And we actually have a graph on the next screen. So let's copy over the equations. X plus y is less than or equal to 500. 2x plus 0.75y is less than or equal to 600. All right? All right, I'm going to count by hundreds here. 100, 200, 300, 400, 500. And 500 would be our intercepts. All right, so we can connect those. That's from this first equation. And then the next one, x is going to be 300. And what if we covered up the next one? 3/4 y equals 600. So we'd have to times by 4/3. 600 divided by 3 is 200, times 4 is 800. So 500, 600, 700, 800 would be way up there. And so we would have to connect these two lines. All right, and so our region then is in here. All right, and it looks like we're crossing right here at 200, comma 300. We have another vertex at 300, comma 0. We have a vertex at 0, comma 0. And we have a vertex at 0, comma 500. All right, and so now let's go and see if we can maximize our profits. If we go back here, it says we can sell at $3.50 per can. So our profit is going to be 3.5x plus 1.5y. And so we can plug all of our numbers in here. So 0, 0, this first point, we're going to make no money, right? We're not selling anything. Let's test this one. This would be 3.5 times 300, which is going to be 900 plus 150, so 1,050. Nice profit. Let's test this point here. 3.5 times 200 plus 1.5, right? Yes, 1.5 times 300. So that's 600, 700 plus 450, which is 1150. So a little bit more money. And then up here, this would be 500 for your y times $1.50, which would be $750. Okay? So clearly, we're going to maximize profit right here by selling 200 and 300. So it was 200 of the mixed nuts and 300 of the roasted peanuts. All right? Your job is to see if you can figure out if you sell mixed nuts for $4.25 a can. Change 350 to 4.25. Are we going to change what we think about what we're going to sell? So go back in there and check your vertices if you change it to 4.25 per can for X. All right, and that's it for this section. So any questions? Talk to me in class.